Hello, I'm V.Simms. I'm a developmental psychologist from the UK, and today I'm going to present to you some data from the PRETERM study, which is premature infant skills in mathematics. And really we're trying to work out if mathematical difficulties in very preterm children is a population-specific problem. So we know that children who are born very preterm, less than 32 weeks gestation, are at high risk for neurodevelopmental disorders. But more commonly, we see general cognitive deficits in this group of children, such as deficits in IQ, difficulties with working memory and visuospatial processing, and also more general deficits in executive functions. Very preterm children also have poorer academic attainment than their term-born peers and are more regularly identified as having special educational needs, requiring assistance in the classroom in order to achieve. Really interestingly, for someone who researches mathematical development, large numbers of studies have found specific deficits in mathematics in this group. And this deficit in mathematics is not accounted for by IQ, which is in contrast, for example, to the deficit seen in reading. And we know from large-scale studies, governmental reports, that mathematical difficulties cast a long shadow over an individual's life chances. And that's not only in terms of academic achievement, that's also in terms of employability and economic productivity. So mathematics is incredibly important. Looking more closely at mathematical learning difficulties, there's a specific learning difficulty called dyscalculia. And this is a substantial difficulty in mathematics relative to IQ, age, and educational experience. From the general cognitive developmental literature, we know that there are a wide range of general cognitive skills and mathematics-specific skills that contribute to mathematical achievement. And in individuals with developmental dyscalculia, we see a specific deficit in numerical representations. And that means a deficit in how people represent numbers in their minds and how they see quantities and numbers working together in a system. If you talk to a teacher who has experienced a child with developmental dyscalculia, they will say that the child lacks number sense. They just don't get how numbers fit together. For example, Brian Butterworth, the father of research in dyscalculia, describes a young man called Charles, who has normal IQ and in fact a university degree, but actually finds tasks like deciding whether 5 is greater than 3 incredibly difficult. There are two tasks that we use with children and adults with dyscalculia, and these two tasks these individuals find incredibly difficult. And I'm just going to give you an example of the two tasks that we use. The first of which is a dot comparison task, where we flash on a screen quite quickly 2 sets of dots, and we ask the individuals to indicate which set of dots contained the greater quantity. It was the set in blue. We also use the similar task with number symbols. And responses to these types of tasks in individuals with dyscalculia are very poor, both in terms of accuracy and response time. And we can use these tasks to assess their quality of numerical representations. So in our study, what we really wanted to look at was to identify the general cognitive deficits associated with very preterm birth. We wanted to really specifically pinpoint the areas of mathematics that very preterm children struggle with. And there are numerous studies that have identified mathematics as being an area of difficulty for very preterm children. But as mathematics is a multi-componential subject, we wanted to really pinpoint the specific areas of mathematics that very preterm children find difficult. And most importantly and fundamentally for this project, we wanted to establish whether very preterm children showed any evidence of dyscalculia. This has been implied by previous research, but has not been evidenced by previous research. So we recruited children who were aged 8 to 10 years old. There were 114 very preterm children and 78 term-born children. The children were assessed at school by a psychologist, and they experienced a battery of standardized and experimental tests. And our analysis is also adjusted for socioeconomic status, which was gleaned from parental questionnaires. Just to kind of give you a flavor of the types of tasks that children completed, the children completed a standardized mathematics test from the Wyatt. We used those two tasks that I've described to you before, the dot comparison and the digit comparison task. We, from the literature, found a set of general cognitive skills measures that we know that very preterm children struggle with, so nonverbal IQ, working memory, processing speed, visual spatial skills, which also fortuitously from the developmental typical literature are very strong predictors of mathematical achievement. We also gleaned from the developmental literature very specific skills that are necessary for mathematical achievement. These are things such as counting, knowing your count word list, being able to count upwards and downwards. Your number fact knowledge, we would describe this as number bonds, knowing that 5 plus 3 equals 8. Strategy use. Do you rely on mature strategies or immature strategies in simple problem scenarios? So a mature strategy would be able to quickly retrieve an answer. An immature strategy is really relying on your fingers. And then finally, we look at conceptual understanding. So we give children problems that are outside of their counting range, and they can only answer these questions if they show some conceptual insight. So returning to our research questions. What are the general cognitive deficits associated with very preterm birth? I'm going to present the results on forest plots of mean differences in Z-scores. And we can see here that as the bar does not cross the zero line, we have a significant deficit in mathematical achievement in our very preterm group. We also see significant deficits in nonverbal IQ, processing speed, working memory, and visual spatial skills. And although processing speeds looks like a strength, actually because it's a speeded measure, this is also a deficit. Moving on to what areas of mathematics do very preterm children struggle with, we noted significant deficits in children's knowledge of the counting word lists, their number fact knowledge, and strategy use. So we see that very preterm children are using immature strategies significantly more than the control children. They rely on their fingers. There's no difference in conceptual understanding. But very interestingly, when we control for working memory and visual spatial skills, these differences in specific mathematics skills disappear. So it seems like the general cognitive deficits are affecting their specific mathematics skills. And returning to the fundamental question of this piece of research, casting our minds back, seeing these general cognitive deficits that we see in our very preterm sample, we want to know, do they show any evidence of developmental dyscalculia? And in fact, we see no difference between the two groups. Very preterm children are performing exactly the same as the control children on this task. This is incredibly interesting, not only in terms of implications for intervention, but in terms of theoretical implications. Here we have a group of children who are struggling with mathematical achievement, but have no issue with numerical representations. They have a completely different etiology than children with developmental dyscalculia. They are also in contrast to other children with neurodevelopmental disorders who have associated mathematical achievement problems, such as children with Williams syndrome, who have numerical representation issues and also poor mathematical achievement. So these children are very special and are a very interesting group of to research in terms of mathematics. So, in conclusion, we see that our very preterm children have significantly poorer mathematical achievement than their term-born peers. They have a different etiology than children with dyscalculia. It's their general cognitive skills, not their numerical representations, that is impacting on their mathematical performance. So what does this mean in terms of implications? Well, we would suggest that we need to develop population-specific targets for intervention. The interventions that have been developed for developmental dyscalculia will not work with this group of children. And this is actually a really positive finding because dyscalculia is notoriously difficult to alleviate. The interventions that have been used with dyscalculia, by and large, are not successful. So actually, we may have some scope here to improve mathematical achievement in very preterm children. We also feel we need to concurrently focus on general cognitive skills. So targeting both working memory and visual spatial skills will probably have a greater effect in this group of children. And finally, we may actually want to approach intervention from a completely different angle. We may want to use a more educational approach to interventions with these groups of children by reducing the cognitive burden in classrooms, such as reducing the burden placed on working memory when doing mathematical learning. So I just want to finish by saying thank you to the children who participated in the research, the teachers and the parents, also to the collaborators that are listed on the screen, and to our funders, Action Medical Research. Thank you.